Hi everyone, so in today's video we're going to be talking about the pH scale. Now the pH scale is extremely useful because it tells us how strong or how weak of an acid or base we have dissolved in a particular solution. So we're just going to go ahead and talk about the scale. So the first thing that's important to know is that the pH scale is actually a logarithmic scale, and it's looking at the concentration of hydrogen ions. So any pH on the scale is actually represented as the negative log base 10 of your hydrogen ion concentration. So what does this mean in practical terms? It means that every single time you increase by a unit on the pH scale, your strength either increases or decreases by a factor of 10. So let's take a look at a scale to clarify this a bit more. So if we see right down here, we have a quick little scale. So if I was comparing something with a pH of 1 to something with a pH of 5, we can look at the differences in strength based on how many units apart there are. So between pH 1 to 5, we have 1, 2, 3, 4 units separating. So that means the difference in strength would be 10 to the power of 4. Or basically 10 times 10 times 10 times 10, which would give us a substance that is 10,000 times stronger. So in practical terms, it's good to know that every single increment increases by a factor of 10. Now, the second thing that's really important about the pH scale is it tells us the three main groups of substances that we have represented, which are mainly our acids, our bases, and our neutral substances. Okay, so now we have our scale in big form, and our first thing that we're going to indicate is our neutral substances. Now, since our scale goes from 0 to 14, 7 in the middle represents our neutral substances. Now, the reason why it's neutral is because it has the same concentration of H plus ions is equal to your concentration of OH minus ions. So they pretty much cancel each other out. Now, our most neutral substance, and it's pretty much the only neutral substance that we have on our pH scale, is water. Now, when we're talking about water, we're actually talking about distilled water, not tap water. So distilled water is basically water that is 2 parts hydrogen and 1 part oxygen. Now, the next category of substances that we have on our pH scale is our acids. So our acids are anywhere from 0 to 6.9. So this is our acid range. The reason why these are our acids range because we have a higher concentration of hydrogen ions than hydroxide ions. And obviously, everything that is close to 0 is going to be strong acid, whereas everything close to neutral is going to be a weak acid. The reason why is because as you're going closer to neutral, the concentrations of hydrogen ions and hydroxide ions are becoming close to equal. And our last category of substances that we have on the pH scale are our bases. So our bases are above 7, so it's going to be from pH 7.1 to 14. Just like with the acids, your strong bases are going to be at pH 14, whereas your weak are going to be closer to your neutral. Because in this case, what's happening is that your hydroxide concentrations are bigger than your hydrogen ion concentrations. And remember from our overview of electrolytes, a base is substance that has a metal and an OH ending, whereas our acids are substances that have hydrogen and a non-metal ending. So now what we're going to do is we're actually going to look at some common examples of acids and bases and where they are on the pH scale. Okay, so here we have another pH scale. Now I just want to let people see, point out over here when we're looking at the colors. So we'll see that on the scale, when it's very, very acidic, it's the colors are red, going on to orange, yellow, green, light blue, dark blue, and then violet. So the reason why we have these different colors is because this scale is actually showing something called universal indicator. So what universal indicator is, it's actually not just one chemical, but multiple chemicals in solution that change different colors depending on the pH value that you have. So it's extremely useful when you're trying to identify the pH value of an unknown solution. Now I want to highlight a difference between the different types of waters that you have on this scale. So if you notice below, we see that distilled water has a pH of 7. So this is pretty much the only true neutral substance that you have. And then you'll notice that we have 3 different other waters on our scale. We have our acid rain, which has a pH of 4.3. We have our clean rain, which has a pH of 5.6. And we have our seawater, which has a pH of 8.1. So this is something that is a common misconception that all water is neutral. It's not. The reason why distilled water has a pH of 7, because again, it's only 2 parts hydrogen and 1 part oxygen. Acid rain and clean rain have dissolved substances in it. Acid rain, the reason why it's considered acidic is because it has lots of gases like sulfur dioxide that have, when they dissolve in water, form a weak acid. So in acid rain, you actually have sulfur dioxide, which is a gas, and it's a main byproduct of burning fossil fuels and combustion reactions. That turns into sulfur trioxide with reactions to other gases in the atmosphere. Now the thing is, sulfur trioxide, in the presence of water, actually forms sulfuric acid, which is actually another liquid that we've used in the lab. And sulfuric acid, well, the key word being acid, is the acid component of acid rain. Now, it's not just sulfur dioxide that is involved in acid rain. You also have nitrogen dioxide and other nitrogen-based gases that form acid rain. So, acid rain, moral of the story, is bad. Seawater, on the other hand, it's actually slightly basic based on the different salts that you have dissolved in seawater. The problem with seawater is that it's actually becoming acidic. So it's acidifying because of our carbon dioxide levels, and that is actually a huge problem due to climate change, which we're not going to be talking about in this video, but we will be talking about it at a later point. Now, the types of questions that you'll have with respect to the pH scale, there's going to probably be 2. Your first would be an indicator type question, which we'll be tackling in another video, and then the next would be acid-base neutralization, which basically means an acid and a base will cancel each other out and form salt and water. So you can actually take a look at acid-base neutralizations in more details. There's about 3 videos that are tackling this, and there's also going to be a video talking about indicator type questions that you would have at the pH scale. Hope this helps, and have a great day.